Well, greetings, Mr. Kolazar's class. Today we're going to start our last section of the year on organic chemistry and the idea of carbon and carbon-based materials. Now, organic chemistry is going to be the study of organic compounds and organic chemistry. We're going to be looking at identifying what hydrocarbons are and the models used to represent them, and then we're going to distinguish between saturated and unsaturated hydrocarbons, kind of at a nutritional level. Now, when we look at organic compounds, they're going to contain carbon is their primary part, and then hydrogen is their secondary part, substances that contain those both. From there, there'll be some other substances, but it's going to be always carbon and how many ever carbons you have, and hydrogen, how many ever hydrogens you have, and then from there, there can be some other substances, oxygen a lot of times, or nitrogen will be a couple of the other substances you occasionally see, but we're going to focus on carbon and hydrogen. Exceptions include carboxyles, so carbon and oxygen, and carbides, carbon bonded to metals with metals bonded to carbon. And then carbonates are the two there that are also exceptions to this rule. So when we look at organic chemistry, a lot of times organic chemistry is going to be abbreviated Orgo. Now, when we look at organic chemistry, it's going to be the study of carbon and containing substances. And this is key. Why is it so important to us? Almost all carbons want to make 4 covalent bonds. Since carbon is able to make 4 covalent bonds to either hydrogen, to another nonmetal, or to another carbon atom, we can start to make long carbon chains and make very complex structures. All of these long chains start to make almost unlimited possibilities. So carbon is our backbone or the basis of all life forms as we know it, and makes so many important substances because of these unlimited possibilities of what carbon can make. Now, what are hydrocarbons? Hydrocarbons are the simplest organic compounds containing only hydrogen and carbon. Hydro and carbon are simple hydrogen carbonations. Now sometimes you'll see carbon, hydrogen is how many carbons to how many hydrogens we have in the ratio of those different compounds are our hydrocarbons. We also have unsaturated and saturated. Saturated hydrocarbons are carbons with single bonds only. A lot of times you're going to hear about saturated fats when it comes to your different foods. So saturated means that they only have single bonds. Unsaturated hydrocarbons with at least one multiple bond, meaning we have a double bond or a triple bond in there. And in those cases, you have less carbons or less hydrogens that can be around each carbon, because all carbons, remember, make 4 bonds. So if you have a double bond, all of a sudden you have less carbons or less hydrogens around each carbon, or a triple bond even less. So as we're going, unsaturated have multiple bonds, so they have less hydrogens around them. Where we might see that in regular life, you hear about good fat versus the bad fats when it comes to foods. So our the unsaturated ones, where we have missing hydrogens, saturated, we have all carbons with hydrogen connected. Unsaturated, we have at least one double bond, so we're missing some hydrogens from down on this bottom part. So when we look at that, the unsaturated fats are the ones we want to look at. They have 2 different kinds, the cis, where both hydrogens are on the same side, versus trans, where one hydrogen is on one side and one's on the other side. So when you hear about cis and trans fats, the unsaturated versions versus saturated versions, that's kind of one of the things that we could see or look at there. When we look at different models for organic chemistry, there's going to be some basic ones. Our molecular formula is just how many carbons to how many hydrogens we have. So our chemical formula, like for methane, 1 carbon to 4 hydrogens. Structurally, what we're going to see here, our structural formula, is going to be when we either have the elements drawn out, and then our single bonds are denoted here, And then the single bond, remember, is 2 electrons being shared, 1 from each atom, as we're going to be shared here. And then we have our ball and stick model, where it's more of a 3-dimensional representation, where we still have showing our single bonds partnering up there. And then another version we could actually see is a space filling model, where each of these would be the electron cloud and where they overlap for each element. So there's some different structures or abilities that we're going to see. But we're going to stop there, and we'll continue on with naming our hydrocarbons next section.